Okay, so for this first region, whenever x is between 0 to pi by 6, so here we can say that x is between 0 and pi by 6, correct? So what is our y dash? Our y dash was 3 cosine 3x. So what will be 3x? 3x will be between 0 and pi by 2. So what will be cosine 3x? The moment we put cosine 3x, we can say that the value will be between 1 to 0, right? So we can say that cosine 3x will be between 1 to 0, 1 to 0, and 3 cosine x will be then between 0 to 3. Okay. Now why is it so? Now first of all, I hope you have understood till this part. Now this part is maybe a bit tricky for some of you. Let me explain now. So look, the cosine curve is something like this. Is it not? This is our cosine curve. This is pi. This is pi by 2. Okay. So look, we are interested in the region from 0 to pi by 2. So we are interested in this region. So the moment we put cosine, the maximum value of cosine is basically 1, and that happens at 0. Okay. Whenever 3x is equal to 0 or very close to 0, it will be very close to 1. And whenever 3x will be very close to pi by 2, it will be 0. So that is the reason 3x will be between 1 to 0. Cos 3x will be between 0 to 1. And hence 3 cos 3x will be between 0 and 3. The important thing is 3 cos x is finally positive. Okay, so we can say that 3 cos x is positive, right? Why? Because 3 cos 3x is positive, because 3 cos 3x is between 0 and 3, which is positive, so 3 cos 3x is positive. So we can say that what is 3 cos 3x? That is y dash. So we can say that y dash is positive. So our derivative is positive in this. This means that y is increasing function, is an increasing function in this region 0 to pi by 6. Okay, so this is the first part of the sum. Now coming to the next part of the sum, I really hope that you have understood this part. This part could be a bit tricky, but I just if you have any problem, just let me know. Okay. The next part. Let's move on to the next part. That is whenever x is between our pi by 6 and pi by 2. So what about that real line? So this was 0 and this was pi by 2, and here we had pi by 6. So this part this part was positive, right? What is positive here? The y dash. Y dash is positive here. Okay. Since y dashed is positive, hence y is increasing. Okay. We are concerned about what is y increasing or decreasing. Okay. But for that we have to study y dashed as well. So yeah, that was the first part. Now coming to the next part, in this region, that is pi by 6 to pi by 2, that is 60 degree or 30 degree to 30 degree to 90 degree. Now, so what is pi by 6 to pi by 2? So x is now between pi by 6 and pi by 2. So what about 3x? 3x will be between, let's multiply entire by 3, we get this pi by 2, and we get this 3 pi by 2. And what about cosine 3x? Cosine 3x. Now let's see. Let us draw the cosine graph again, and let us see what happens to the cosine in this interval. Suppose we have this cosine graph here, some like this maybe. Okay. So this is pi by 2, this is pi, this is 3 pi by 2, this is 2 pi. So we are interested in looking at this region pi by 2 to 3 pi by 2, that is this region. Okay, in this region. So in this region we can say the 3 cosine x is, whenever it is pi by 2 it is 0, and 3, so it is, so so okay, so look, in this region our cosine 3x will definitely be negative. Okay, so we can say that our cosine 3x will be negative in this region. That means our 3 cosine x should also be negative. Right? Why is cosine 3x negative? Why can we say that cosine 3x is negative all of a sudden? Well, look, this is basically the graph of cosine 3x. This is the graph of cosine x actually. This is the graph of, and we can see the cosine x, whenever x is between these 2 points, it is basically between those, it is always negative. Whenever it is between, the x is between pi by 2 and 3 pi by 2, it is always negative. So we can say that if our angle, this 3x or whatever, this theta, if it is like, if you have a problem, you can say that 3x is equal to theta. Okay, it will make things easier really. So we can write this as like this, that it is between theta and 3 pi by 2. Now let this be cos theta. Okay, now so whenever our theta, so let this be theta. Okay, now whenever cos theta is between these two, cos theta is negative, so our theta is between these two regions. Whenever theta is in between these two regions, our cos theta becomes negative. So after this we can say that our cos theta becomes negative. So now we can replace back again that cos 3x is negative. Okay, so more importantly, that again 3 cos 3x is also negative. That means our y dash is negative. So y dash is negative, that means what? Y is decreasing function here. In this region y is decreasing. So finally we can say that this is 0, this is pi by 2, and here we have pi by 6. So here our y was positive, so y dash was positive, so y is increasing, and here y dash was negative. Okay, y dash is negative, so y is decreasing. So yes, so in the interval 0 to pi by 6, finally we can say that in the interval 0 to pi by 6, this cosine 3x, sine 3x is increasing function, right? And in this region sine 3x is a decreasing function. That's it. So this was one of the first questions for today. Next, let us try out another sum, maybe cos 3x. Let's try out cos 3x. What about cos 3x in the same interval? Okay, say y is cos 3x in the same interval from 0 to pi by 2. We will try to study that where is it increasing and where is it decreasing. Okay, so what is y dash? First of all, y dash will be negative 3 sine 3x. Nice. Now find the critical points. So y dash is equal to 0. So let's find the critical points. Y dash is 0, so minus 3 sine 3x is 0. That means sine 3x is 0. Where is sine 0? Sine is 0 on these 2 points, right? On the x-axis. Whenever the point is on the x-axis, the sine is 0. That means our 3x should be, maybe it will be 0 or pi by 2 or 2 pi or sorry, not pi by 2, this is pi. This point is pi, right? This is 0, 2 pi or 3 pi and so on. these values. But we will take only these two values, I guess. No, we should take only these values 0. So 3x is basically equal to 0. So that means x is only, x should be 0. Why am I taking only 0? The reason is this, that our region is 0 to 0 to what? It is basically 0 to pi by 2. So from 0 to pi by 2 we have only 0, right? So let's do one thing. Okay, let's do one thing. Let us increase this interval from 0 to suppose 2 pi. Okay, then our critical points we will also include these two here. Okay, in this way we will make it a bit more interesting, I guess. So x will be 0, pi by 3 and 2 times pi by 3. So these are the 3 points where our y dash will be equal to 0. So nice. Now let us draw our line, number line, and this is a 0. So this is our pi by 3, this is our 2 pi by 3, and let this be 2 pi. Okay. So what is pi by 3? Pi by 3 is basically 60 degree, this is 120 degree, and this is 180 degree, and this is obviously 0 degree. So we have these 3 critical points. So these are the critical points. Okay. I will put bold dots here to understand that these are critical points. These are the points where our y dash is becoming equal to 0. Okay. Now, so how is y dash behaving in these regions? So once we have put three critical points, so this is our line, right? So we have 3 regions. You can see we have 3 regions now: 0 to pi by 3, then pi by 3 to 2 pi by 3, and then 2 pi by 3 to 2 pi. Now look at one thing, notice one thing. Even in the previous example and also in this example, we are not including these critical points. Okay, look, we are not including 0 or pi by 3 in any of these regions. The reason is this, that if we include these points, then what happens is um, our y dash will become equal to 0 there. But we want y dash to be positive or negative. We don't want our y dash, our dy dx, to be greater than equal to. We don't want something like this, that y dash is greater than equal to. We don't want this. We want y dash to be greater than 0 or y dash to be strictly less than 0. These things we want. We don't want this either. Okay. Now, what is the reason why do not we want this, but we are we are entertaining these two? The reason is very simple. Look, y dash is when it is greater than equal to 0, it means this will be monotonously increasing. Monotonously increasing, and this means it is monotonously decreasing. But we have not been asked about monotonous increasing or decreasing behaviors. We are asked about increasing or decreasing. So these are basically, this is basically increasing or strictly increasing, and this is basically strictly decreasing or simply decreasing. Okay, so that is the reason why we are entertaining these two equations and not these two equations. If they are asking us to find out for also monotonously increasing functions, then we will definitely take these two as well. But but for this example, we are just asked about increasing and decreasing functions. Where is our function increasing and where is it decreasing? So I hope it is clear. Now the next part is y dash is greater. So where is y? So where is our y? That is what is your y? Our y was probably cos 3x, right? So where is y increasing? Y is increasing wherever the y dash is positive. And what is our y dash? Our y dash is minus 3 sine 3x, right? Now, so let us, wherever this is positive, so let us first of all let us start with this region. we don't know that which region in which region the function is behaving in which way. So we shall start with this region. So whenever the x is between 0 and pi by 3, so it means that it is between these 2 points. This means 3x is basically 0 and pi. This means sine 3x. So let 3x be let theta be equal to 3x for our understanding, better understanding, easy understanding. And so let us draw the sine theta curve now. So this is theta, let this be sine theta. So this is sine theta, right? Something like this. So from 0 to pi, so this is pi. So look, if from 0 to pi, sine theta is always positive. Look, it is always between 0 to 1. So we can say that sine theta, whenever theta is between 0 to pi, sine theta will be greater than 0. Obviously, right? Why? Because from 0 to pi, our theta is basically, when theta is basically between 0 and pi, our sine theta is, at least it is 0 and at most it is 1, right? What is this value? This is 1. So sine theta is positive. So it means sine 3x is positive. This means that our 3 sine x is positive. And this means the minus 3 sine x will be negative, right? Which means our y dash will be negative. So in this region, let me draw it somewhere else. So this means in this region from 0 to pi by 3, right? So in this region it is decreasing. So in this region our y dash is less than 0, so y is decreasing function. Y, what is y? Y is basically cos 3x is decreasing function. So in this region it is a decreasing function, cos 3x. Right, now let us look for the next region. Go into the next region and see that what is happening there. This is pi by 3. What was that? So I guess it pi by 6. I guess this was pi by 6, or I don't remember. Anyway, let's find it out. What was y dash? Y dash was equal to 0. So it is 3. Sine 3x is equal to 0, negative sign. So this means sine 3x is 0. Sine 3x is 0. It means that 3x will be 3x will be either 0 or pi or 2 pi or 3 pi and on so on. So we will take these three values. So this will be 2 pi by 3. So x will be 0, pi by 3, 2 pi by 3, pi and so on. Okay, so this was pi. Okay, so we should take pi as well. Pi is also a critical point. So pi by 2 pi by 3. And pi is also taken, okay? Why? Because pi is also a critical point. Okay. Now let us move into the next region, that is pi by 3 to 2 pi by 3. So when x belongs to pi by 3 to 2 pi by 3, what is happening? Let's see. So in this region, x is between pi by 3 and 2 pi by 3. So 3x is between, let us multiply by 3, which is between here. So what about how will sine 3x behave? So this is between pi and 2 pi, so pi and 2 pi. So look, sine theta, let this be theta, 2 pi and pi. So sine theta will be negative here. If sine theta is negative, that means sine 3x is negative. 3x is equal to pi, okay? and that means sine 3 sine 3x is also negative. This means minus sine 3x is positive. So our y dash is positive. So in this region y is actually y dash is basically positive and y is hence increasing. This is in this region. What about this region? This is the third region. Okay. When x is between 2 pi by 3 and pi, what is happening? We have a 2 pi by 3. So what is this? So what will be 3x? 3x will be 3 pi and 2 pi. 3 pi and 2 pi. So theta is between 3 pi and 2 pi. So let us draw the curve. This is pi, this is 2 pi, this is 3 pi. So look, between 2 pi and 3 pi our sine theta is always positive, so we can say that sine theta is positive here. That means sine 3x is positive here. That means our 3 sine x is positive here. That means minus 3 sine x is negative here. That means y dash is negative here. That means y dash is less than 0. That means y is decreasing function here. So yes, so that's it, I guess. So what do we have finally? We have something like this, that in this region from 0 to pi, right, we had pi by 3, 2 pi by 3, pi and 0, these 4 critical points of this function cosine equals to 3x. Cosine 3x has 3 critical points, 4 critical points, sorry. 4 critical points is 0, pi by 3, 2 pi by 3 and equals to pi. So okay, wait a minute. These 4 critical points are not of cosine 3x, okay. These 4 critical points are of the derivative of cosine 3x, that is of minus 3 sine 3x. Minus 3 sine 3x has these 4 critical points, not cosine 3x, okay. And minus 3 sine 3x is basically positive here. No, it is negative here, so y dash is negative here, y dash is positive here, and y dash is again negative here. So we can say that our y is increasing in this way, in this region, it is decreasing in this region, y is decreasing in this region, sorry, y is increasing in this region, and y is decreasing again in this region. So yes, so that's it, I guess it was clear, and let us move into the next sum. Okay, what is our next sum? So look, let us do something with logarithm, perhaps, maybe this sum. So let fx be equal to x by logarithm of x base e, okay, and we have to say that where is it increasing and where is it decreasing, okay. So we have the entire real line, we have to say that where is it increasing, where is it decreasing. So what is f dash x first of all? So y is x by logarithm of x base e. So this is a natural log, right? So I guess you people remember what logarithm was. So if you don't, then probably I will make not here, but I guess you guys know already what is log, right? So if you have a base of e, it means it is natural log. Whereas if you have something like this, x base 2, this is not natural log, okay? This is a base 2 log, okay? And so let us find out y dash. What will be y dash? Y dash will be something like this. So in a natural log, you can leave the base blank. If the base is not given, it means that in the base you have an e, right? E is basically the Euler's number. Hope you guys remember this. So on the derivative of this, so you will find it is log x base e ddx of x minus of x ddx of logarithm of x base e. Okay, so I will simply write log x into 1 minus x into 1 by x divided by log of x whole square. Okay.